Hi everyone. So we'll solve the congruencies by using Chinese remainder theorem. So in our step 1, x is congruent to a1 modulo m1, x is congruent to a2 modulo m2, x is congruent to a3 modulo m3. So we have to check first GCD of 43, 49 and 71, is it 1 or not? If it is not 1, we cannot apply Chinese remainder theorem. So checking GCD of 43 and 49 and 71 is equals to 1 or not. Since all the 3 are primes, is equals to 1. Therefore, the GCD is equals to 1. The GCD of a prime is 1 or itself. But here it cannot be itself, right? So here it is 1. So coming to step 2. X is congruent to m1 x1 a1 plus m2 x2 a2 plus m3 x3 a3 modulo m, capital M. This capital M is m1 m2 m3. So m1 into m2 into m3, that is 43 into 49 into 71. We get as 149597. So capital M1 is equals to capital M divided by small m1, which is equals to 43 into 49 into 71 divided by 43. So which is 49 into 71. That is 3479. So m1 x1 is congruent to 1 modulo m1. Out of this we have to find x1. So 3479 x1 is congruent to 1 modulo 43. So now 39 is less than 43. So 39 goes to that hand side, it becomes 39 inverse modulo 43. This 43 can be written as 43 is equals to 39 into 1 plus 4 by extended Euclidean algorithm. We can just find the inverse of the number. That is 43 is equals to 39 into 1 plus 4. 39 is equals to 4 into 9 plus 3. 4 is equals to 3 into 1 plus 1. So from here, going on back ways, that is 1 is equals to 4 minus 3 into 1. That is 3 is equals to 39 minus 4 into 9. 4 is equals to 43 minus 39 into 1. So by going on back ways, we get 1 is equals to 4 minus 3 into 1. Now just substitute the value of 3 and 4 in this in order to get something like AU plus BV format. So where minus 11 into 39 plus 10 into 43. So x1 is congruent to minus 11 into 43. Here as you can see 39 ka coefficient is minus 11. So this minus 11 is going to be the inverse of 39 modulo 43. So m2 is equals to capital M divided by small m2, which is 43 into 49 into 71 divided by 49, which is equals to 3053. So m2 x2 is congruent to 1 modulo m2. Now this 3053 is greater than 49, right? So you can just divide it by 49 and get the remainder. The remainder will be 15. 15 into x2 is congruent to 1 modulo 49. x2 is congruent to 15 inverse mod 49. So 49 can be written as 15 into 3 plus 4. 15 can be written as 4 into 3 plus 3. 4 can be written as 1 into 3 plus 1. Now going the reverse way as same. So 1 can be written as 4 minus 3 into 1. Just substitute 4 and 3 value. And back then substituting we get as 1 is equals to 4 into 49 plus minus 13 into 15. x2 is equals to minus 13 modulo 49. That is inverse of 15 is minus 13 modulo 49. So now similarly m3 is equals to m divided by m3 is equals to 43 into 49 into 71 divided by 71. m3 x3 is equals to 1 modulo 49. m3 का value is 2107. x3 is congruent to 1 modulo 49. Same dividing by 71 we get 48. x3 is congruent to 1 modulo 49. 48 inverse modulo 17. So repeating the same procedure by extended Euclidean algorithm, we get x3 is congruent to minus 34 modulo 71. x1 x is equals to m1 a1 x1 plus m2 a2 x2 plus m3 a3 x3 modulo m. Here capital M a1 x1 and m2 a2 x2 and m3 a3 x3 value, if we substitute and add up the things, mod capital M, we get some values like this. If we add on and then just divide it with 149597, we get minus 137864 modulo 149597. So x is congruent to 11733 modulo 149597. In this way we can solve the congruences. Thank you so much for watching. Please do comment your doubts.